This is the second part of Chapter 4 video. So the first thing we're going to look at is conditional expressions. When we have a very simple if and else. So if we have an if and it does one thing, and then we have an else and it does one other thing, then we can rewrite this in what's called a conditional expression. So let's actually go down and take a look at the participation example. So if I have if a condition, whatever the condition is, my variable equals expression 1, else my variable equals expression 2. This requires 4 lines of code. This conditional expression, that's what it's called, conditional expression, allows me to write this in 1 line of code. So I want to assign my variable to expression 1 if the condition's true, else I'm going to assign it to expression 2. I only have to put my variable in 1 time. So this is a little tricky to get used to, but it's not too bad. So here, 4 lines of code. My variable equals expression 1 if the condition is true, and you'll put whatever condition is in there, else expression 2. So what we want is for y to be equal to 0. This is participation 4.9.2. If x is less than 100, else we want it to be x. And we'll check that and see if it's true. Now in the conditional expression that we looked at above, it had parentheses around the conditional expression, around the conditional part. The comparing part, is x less than 100. So we'll check this and see if we need it. So it doesn't need the parentheses, but it looks like it's convention for the parentheses to be in there. So I recommend you do that convention. But you can see I'm picking the part. This is what I want to be true if x is less than 100, else I want it to be x. In the challenge activity 4.9.2, we want to evaluate string to be negative if user value is less than 0 and non-negative otherwise. So that pretty much is what you're going to be writing. There's the pseudocode. So I want the conditional string, that's the CONDSTR, to be negative if user value is less than 0. That's pseudocode, so you'll have to change some of that code. And the and here, and otherwise would be the else. For the challenge activity 4.9.3, just a heads up that increments means that I'm going to be adding 1 to it, and decrement means that I'm going to be subtracting 1 from it. I've put a bonus assignment on Canvas for this additional practice for the TweetDecoder. It's using idle to create your file and running your file in idle, so it gives you a little more practice in idle. It is 25 bonus points in the homework category. In the 4.11 lab, they show you how to convert RGB colors. So if you go to this page, you can see the conversion for the hexadecimal colors. Hexadecimal numbers are, instead of base 10, they're base 16. So that would be the number 0 through 9 would give you through 9. A is the number 10, and all the way to F would be the number 15. So it's 16 digits, 0 through F. There's a color mixer here, so you can see, you can try different hexadecimal ones. You can try some random ones and see what those numbers should be, or you could actually pick some. There are other RGB color pickers online, so if you look it up, you can see other people's perceptions of what the RGB should actually be. So our exercise is to remove the gray. So if you have equal amounts of red, blue, and green, that is actually contributing to the gray. All zeros would give you black, and all 255s would give you white. There is no 256, so if you end up with 256, you end up with no color, actually an error in your code. 40, 40, 40 is a dark gray, so that's equal parts dark gray. So white, black, and dark gray are like equal parts of red, green, and blue. So that's what you're seeing there. So here, all we're trying to do is take out the smallest number from all 3 of the numbers that are given. So here we took out 80 minus 50, 130 minus 50, 50 minus 50, and 130 minus 50, and we end up with another color. So given three numbers, we're going to have to figure out what the minimum is and subtract it from each of the three and spit out the new numbers. For the 412 lab, we want to have three numbers given to us, and they're going to be integer inputs, and we want to find the minimum and output it. So there is a quick way to do this with list. So I'm showing you my code here for list. So I have a variable that I'm storing three numbers into, but I'm asking for all three of these numbers. And then of course I can find the minimum of a list. So this is real quick code, but that's not what this exercise is supposed to be about. I did get all points, so you could make it like this, but let's actually talk about how to do this with if-else. So you might call your numbers X, Y, and Z, or A, B, and C, or number 1, number 2, number 3. I'm going to call mine A, B, and C. A, B, and C. And each one of these I want an input equals an integer input. That's what I was asked for. So this goes back to old code. And then B would have the same thing. C would have the same thing. Now I'm going to assume that A is the smallest one, so I'm going to store in what's called the dummy variable. I'll just call it SN for small. I could call it min, that would be fine too. Small equals A. So then I have a couple of if statements that I need to put in. So I'll write if B is less than small, oops, then we'll put B equals small. Well, sorry, small equals B. Now we have an elif C is less than small, then small equals C. So this has gone through. It's said that A was the smallest one, but if B is smaller, then we'll rewrite it. Now B is the smallest one. And I don't really want an elif now that I'm looking through because I want to check to see for C too. So this is just an if. So if C is less than small. So we're comparing all three of these. This idea of a dummy variable is a pretty conventional thing all through any kind of programming anywhere. They use dummy variables like this. So then I want to print out print small. And that should do it. So looking back over the code, I noticed a couple of things that I should have in here. All the ifs have to have a colon, and I didn't put a colon, so let's do that. If, elif, and else all need a colon after the conditional that you have in there. So I hit submit and everything passed. The 4.13 lab it looks like a train wreck of if and thens and else's, but it's not really. So if you take a moment here, you can use the numbers between 1 to 999. So your program should accept any of the numbers from 1 to 999. So you're just getting one input, and then you're outputting a sentence depending upon what you've been given. And there are lots of ways to do this. I'm going to see this done in an awful lot of ways, I'm sure. So if it ends in an odd number like 5 or 95 or 93 or 91, then it goes north-south. And it ends in evens, it goes east-west. So you can determine an even number by, if you divide by 2, you end up with 0. So there's your hint. To divide by 2, you would have a remainder of 0. That gives you even. So the others would be odds. So that's an if-else thing right there. The auxiliary highway numbers are 100 and 999. The service roads end up being just dropping the 2. So we've done one before where we dropped the 2. And that basically is another remainder. So if you divide by 100, you drop the first digit. But you have to first determine whether or not you have a bigger digit. So for instance, if you're given 90, I-90 is primary, will be spit out. So your numbers there, the I dash and is primary, Mary is going to be standard for the output for this one. And then it's either going east-west or going north-south. So there are two variables here, the input that came in and whether it's going east-west or north-south. So if the input is 290, there's going to be two variables, 290. There's actually three if you count the 90 here, and then the east-west. So if the input is 0 or any other digit outside of 1 to 999, then you're going to print out that that number is not a valid interstate highway number. So these are just typical sentences that you're going to have to print out. So this one shouldn't be too hard, but it's going to be a little tedious, so make sure you allow yourself enough time to do it. In the 4.14 lab, seasons, you're going to be given, or you're going to ask for input of a month, so a regular month name, and a day, and determine what season that belongs to. And there's a little list down here where those seasons are. It also tells you that you're going to check the input and see whether it's valid or invalid. So first, let's just do the seasons. I know I'm going to need this information, so I'm going to copy this down and make it into a quote. So I have that there. Now 3 quotes there allow me to keep the whole thing as one block in a quote. So I've got that information I need. I also need to print out invalid if it's not valid. If the number's wrong and if the month's wrong, either or is wrong, then I'll print out invalid. So I'm going to have to come up with a way to check all of the months. So I might put the months into a list so I can check to see whether or not the name that's given to me is in the list, and then another list for each one of the dates so that I can check and see if the date is the correct one. So there are a lot of ways to do this. You could do a bunch of if-else statements and go just what I would call brute force programming straight down the page and end up with everything is an if-else. So you could do it that way too. So if that's the way you're thinking, have at it. That's a good way to program sometimes too. Since I'm going to have to know how many days are in each month, and I know, but not everybody really remembers, and all the different month names, then I'll need to maybe go look it up. So I looked up the months of the year and how many days are in each of them. We're going to use February's 28th, period. So just for this programming practice, we'll use that February's 28th. We're not going to check from years because that's not being input. So we need all of these days and dates